Hey everyone, in this video we're going to be looking at Chapter 6 of Effective Engineer, which is called Validate Your Ideas Early and Often. The first section is called Find Low-Effort Ways to Validate Your Work. It discusses the importance of iterative approaches when working on projects, particularly when the path forward is not clear-cut. The author uses the example of a self-driving robot they built for a competition, which taught them that minor variations can cause errors to compound over time, leading to wasted effort and veering off course. By moving forward in smaller iterations and continuously collecting data to correct course, we can reduce the risk of errors compounding and increase our chances of success. The author emphasizes the importance of validating our work with small efforts, even if it means adding 10% extra overhead. This can help us gain a better understanding of risky issues that impede progress, allowing us to either address them early to increase our chances of success, or change course to a more promising avenue. The author also discusses the concept of the minimum viable product, MVP, which allows teams to collect the maximum amount of validated learning about customers with the least effort. Building an MVP requires focusing on high-leverage activities that can validate hypotheses about users as much as possible, using as little effort as possible to maximize the chances of success. The text also provides an example of Drew Houston, the founder of Dropbox, who built a short 4-minute video as his MVP to validate his belief that users would prefer the seamless user experience his product could provide. Overnight, Dropbox's beta mailing list grew from 5K to 75K users, validating his premise and allowing him to build confidence in his product without investing too much work. The author encourages engineers to think creatively when building MVPs and to validate their work with small, informative prototypes before investing significant effort into large-scale projects, such as migrating to a new software architecture or rewriting a service in a new language. The next section is called Continuously Validate Product Changes with A/B Testing. It talks about the importance of using data to validate ideas in order to achieve high-leverage results. It uses the example of Barack Obama's 2012 re-election campaign, where his digital team used A/B testing to optimize email campaigns and raise millions of dollars in donations. The team tested 10,000 different variations of subject lines, email copy, donation amounts, formatting, highlighting, font size, and buttons, and found that the best variations often raised 5 to 7 times as many donations as the worst ones. The heavily tested fundraising emails raised the majority of the Obama campaign's $690 million via online donations, making the investment of the team's time well worth it. The section also explains the concept of A/B testing, where a random subset of users sees a change or new feature, and the results are compared to a control group that does not see the change. A/B testing provides a scientific way of measuring the effects of a change while controlling for other variations, which allows for a more accurate assessment of the impact of the change. This approach encourages an iterative methodology to product development in which teams validate their theories and iterate towards changes that work. The section further discusses the case of Etsy, an online marketplace for handmade crafts that built its own A/B testing framework to continuously experiment with its product and measure the effects of those experiments. When Etsy's team redesigned the product listing page for a seller's item, they used A/B testing to reduce bounce rates, clarify to shoppers that they were purchasing from independent designers, makers, and curators, and made it easier for customers to shop and check out quickly. The results of the A/B test allowed the team to measure the impact of the changes and make data-driven decisions on how to proceed. The next section is called Beware the One-Person Team. The section delves into the risks associated with one-person projects in software development and the importance of getting feedback early and often. The author shares a personal experience of building a search feature for Google's social networking site, Orkut, and submitting a multi-thousand-line code review to their mentor. The risks associated with one-person projects include lack of feedback, demoralization, and lack of accountability. However, the risks are surmountable, and the author advises creating feedback channels to validate ideas and prevent wastage of effort. The author uses the example of Steve Wozniak, who designed the hardware and software for the Apple I and Apple II by himself, but had Steve Jobs as a counterbalance and feedback loop. Now, with that being the case, the last section is called Build Feedback Loops for Your Decisions. The section talks about the importance of building feedback loops in various aspects of work, including large implementation efforts, product development, team coordination, and decision making. The principle of validation can be applied to any decision, and it involves formulating a hypothesis about what might work, designing an experiment to test it, understanding what good and bad outcomes look like, running the experiment, and learning from the results. The author emphasizes that validation can be difficult, especially when there are few data points or only qualitative data available. For example, when deciding which programming language to use for a new service, what the abstraction or interface should look like, or whether it's worth investing in more scaling right now, validation can help inform decisions. Moreover, the more senior an engineer becomes, the tougher and more nebulous their decisions become, particularly if they enter into management. Coordination of teamwork, reducing technical debt, giving feedback, and arranging compensation structures are just some of the challenging decisions managers must make. The author highlights that any decision made should have a feedback loop, otherwise the decision is merely a guess. Overall, the key takeaways for this chapter are that you should approach a problem iteratively to reduce wasted effort, to use A/B testing to validate your product hypotheses, and to find out ways of soliciting regular feedback from others when working on a project alone. So that's all for this one. My name is Daniel, and I make programming-related videos, sometimes coding tutorials, and others more abstract, like book chapter summaries. I do it not only because I love teaching you, but I love learning for myself as well. So if you found this video and this series helpful or thought-provoking, I'd appreciate a like, subscribe, and comment. I love hearing from you, and we'll see you all in the next one.